Okay, so you're probably going to hear some chatter in the background and some kids playing and stuff, but you know, that's just my life. So welcome to a little glimpse into the chaos. Uh, anyway, but let's walk through a couple of these circle examples um, using the area of the circle formula. And so in each of these examples, I just want to find the area of the given circle. Here we're given the radius, right? We're told the radius is 6 centimeters. This is a pretty simple problem. You should be able to work it out. So go ahead and give the video a pause and see if you can find the area. Give me both an exact answer and a decimal approximation. I'm going to go ahead and work out my solution now, right? So we know that the area is pi r squared, right? We just proved that formula. And in this case, the r stands for the radius, right? In this case, the radius is 6. So the radius, or the area, would be pi times 6 squared. Or in other words, 36 pi square centimeters, right? So we're going to say 36 pi square centimeters. So that's one, that's the exact answer, right? So that would be the exact answer to the question. If we wanted the approximation, then of course we can just plug 36 pi into the calculator. And that's about 113.1. This is about 113.1 square centimeters. And by the way, you'll notice that the units are square units, right? And it makes sense algebraically. It's like really what we did is we squared 6 centimeters. So what you get when you square 6 centimeters is 36 square centimeters, right? Anyway, so that's that one. Now let's do another one, similar, right? We've still got a circle. We've still got 6 centimeters labeled on this circle, but this time it's not the radius, it's the diameter of the circle, right? So go ahead and give the video a pause and see if you can work this one out. Okay, now here's my solution. Again, you know, the area is pi r squared. We weren't given the radius, though. We were given the diameter. We know that the diameter is 6 centimeters. So if the diameter is 6 centimeters, then the radius must be 3 centimeters, right? Since the radius is half of the diameter. So, so we'll plug in 3 for r this time. We're going to say a equals pi times 3 squared. That would be 9 pi square centimeters. Or as a decimal approximation, you get about 28.3. So that's approximately 28.3 square centimeters. So there you go, a pretty big difference in area, right? So when you double the radius, you more than double the area, which makes sense because the radius is being squared in this formula. So anyway, so that's the idea on those two. I want to give you one more similar. So here we've got another circle. This time the entire circumference of the circle is 6 centimeters. This one a little more challenging than the previous two, I suppose, but go ahead and give the video a pause and see if you can work this one out. Okay, now here's my solution. We know that the area is pi r squared. So we know that we need to figure out what the radius is in order to be able to use this formula. We're not given the radius though, so let's see if we can figure it out, right? So we know that the circumference is 2 times pi times the radius. So, and we know that the circumference is 6 centimeters. So 6 equals 2 pi r. We can solve for r now, right? So we would divide through by 2 pi. Divide through by 2 pi in order to solve for r. We get r equals 6 divided by 2 pi. You can simplify that, right? So r is 3 over pi. Now, my advice would be don't change this into a decimal just yet, because you're going to be plugging this value into another formula. And for one thing, you might find out that some pi's will cancel off. For another thing, if you round this value now and then you use it in another formula, you're going to end up with rounding errors in your final answer. So you're better off using the exact value until you're ready to present your final answer. Okay, so I'm just going to work with this as 3 over pi. I am not going to change it into a decimal. But that's our radius. So we can plug that in now. We can say the area is pi r squared. So in this case, that would be pi times 3 over pi squared. Now don't cancel the pi just yet, okay? Because order of operation tells us we've got to take care of the exponent first. So I'm going to square this value first. I'm going to get pi times 9 over pi squared. But now I can cancel off at least one of the pi's, right? I can cancel that pi with one of these pi's there, and I get 9 over pi. That's my exact answer. Okay, so the area of this circle is 9 over pi square centimeters. So that's my exact answer. This is approximately 9 divided by pi is approximately 2.86 or 2.9. I guess we've been rounding to one decimal place, so we can just round 2.9 square centimeters. Okay. And that's that one. Okay, so so just be careful, right? Make sure that that you're using the information that you're given appropriately. So those are just kind of some basic, I think some basic examples. Of course, we could go the other way around here. We could be given an area and then be asked to find the circumference, right? But I'm not going to take you through all the nitty-gritty details. You should be able to work that out. If you understand what these formulas are, what they mean, where they come from, you should be able to work that kind of stuff out if you're presented with it. What I did want to do is give you a couple more challenging problems. See, and I can't count because I originally labeled this example 3, but this is our 4th example, right? So what I want you to do on this problem is try to find the area of the shaded region. So try to find the area of the washer. The picture might not be drawn perfectly, but this is supposed to be 2 circles and they have the same center. So they're both centered in the same spot. So this 7 inches, right, it's uniform all the way around, or at least it's supposed to be. Again, it's not drawn perfectly, but that's the idea. So go ahead and give the video a pause. See if you can work this one out. Okay, so now here's my solution. The way I'm going to work this out is I'm going to find the area of the big circle, and then I'm going to subtract off the area of the small circle. And that'll get me what's left over, right? That'll get me this kind of washer or this little disc area. Well, I guess it's more of a washer than a disc, right? Yeah, so I'm going to do area of big circle minus area of small circle. So the area I'm interested in, maybe I'll label it like this, right? The area of this little washer is going to be the area of the big circle minus the area of the small circle. Now the area of the big circle isn't difficult to find. We're given the radius of that big circle, right? It's 20 inches. So we can say the area of the big circle is pi times 20 squared, right? Pi r squared. For the small circle, that might be a little more difficult. Well, maybe it's not terribly difficult, but it does require us to do a little bit of scratch work. If we know that this radius is 20 inches and this distance is 7, what we're looking for is the radius of the small circle. So we're looking for this little radius here. Right. Whoops. So we're just looking for this little radius right here. Well, if we know that from here to here is 20, and from here to here is 7, then that must mean that from here to here is 20 minus 7, which is 13, right? So this should be 13 inches right there. Okay, so the area of the washer is area of big circle, pi times 20 squared, minus area of small circle. That would be pi times 13 squared. Okay. Again, I'm not going to change this to decimals or anything, at least not yet. I know that 200 squared is 400, right? So this is 400 pi minus, and then I know that 13 squared is 169. Is it? Yeah, it's 169. Whew, 169. So I have 400 pi minus 169 pi. That's 231 pi. So this is 231 pi. And again, this is square inches this time, right? So that's my exact answer, 231 pi square inches. And as a decimal, that's approximately 725.7. .7 square inches. Okay. So that's that one. And then I want to give you one more, just one more, that will work out together. So I want to do this problem right here. I guess it goes without saying, right? You probably should pause the videos so that you have some time to draw this stuff. But this is supposed to be, basically it's a square with a quarter circle cut out. And the area that I'm interested in is this little boomerang type shape. So it's sort of like a boomerang looking thing. So go ahead and give the video a pause. See if you can, you will draw the figure, of course, but then see if you can find that area. Okay, so now here's my solution. I'm going to do a very similar thing to what I did before, right? If I want to find, if I want to find the area of this boomerang, then what I can do is find the area of the entire square and then subtract off the area of the quarter circle, right? So it's going to be the area of the entire square minus the area of the quarter circle. Okay, so let's see the area of the square. Now that part's easy, right? This is the area of the square is just base times height, or length times width, or whatever you want to call it, but it's 10 times 10, right? So it's 10 times 10. The area of the quarter circle, well, the area of the whole circle, if you can imagine like the whole circle being drawn out, right? The area of the whole circle would be pi r squared. But we only want a quarter of that. So it's going to be pi r squared divided by 4, right? That's the area of this little quarter circle. It's pi r squared divided by 4. So all I need to know is the radius of the big circle. Well, if you imagine drawing out this whole entire circle, right? So if you imagine that the whole thing was filled in, this would be the center of the circle. And that means that this length right here is the radius. And so is this length, right? They're the same length. They're the radius. And you know that since this shape is a square, this radius must be 10 centimeters. Okay, so the radius of the big circle is 10 centimeters. So the area of the quarter circle is going to be pi times 10 squared, right? Pi r squared divided by 4, since I only want a quarter of the circle. Okay, so let's work this out now. So we're going to have 100 minus 100 pi divided by 4. Now you can get a common denominator and combine the fractions. If I get a common denominator, I would multiply by 4, right? I'm thinking of this as 100 over 1, right? And I multiply by 4 over 4. So I get 400 divided by 4 minus 100 pi divided by 4. So that's going to be 400 minus 100 pi divided by 4. That's I think as simple as it's going to get. Right? That's your exact answer. And this is square centimeters. All right? So there's your exact answer. Actually, there's nothing wrong with this answer either. The answer that we kind of originally got, right? You could have called that your answer as well. But if we want to change this into a decimal, let's see how much this is. So I'm going to plug this into my calculator. Just be careful you're using correct order of operations, right? So if I'm going to plug it in this way, I need to make sure that I do 400 minus 100 pi and then do that before I divide by 4. In other words, if I just type in 400 minus 100 pi divided by 4 like that, it's going to give me the wrong answer. You see, and my calculator will display it, and it'll show you that it's wrong because it's only dividing the last term by 4, and you want to divide the whole thing by 4. So in order to get that to happen, what I really need to do is put this part in parentheses. See, and now it displays it the way that it's meant to be displayed, and then it gives me the answer there. Alternatively, you could do it like this. You could do the numerator first, 400 minus 100 pi, and then hit enter, and then say divide by 4. And that'll still give you, you see how it gives me the same result, right? But anyway, I'm interested in knowing what this is as a decimal. So as a decimal, that's about 21.5 square centimeters. Okay. And that does it for that one.